Section 14.4, Flaws of the Apportionment Methods. Upon completion of this section, you'll be able to determine if a given apportionment demonstrates the Alabama paradox, the population paradox, or the new states paradox. There are three flaws of Hamilton's methods: the Alabama paradox, the population paradox, and the new states paradox. The flaws apply only to Hamilton's method and do not apply to Jefferson's, Webster's, or Adams' method. The Alabama paradox occurs when an increase in the total number of items to be apportioned results in a loss of an item for a group. Example, consider Stanhope, a small country with a population of 15,000 people in three states, A, B, and C. There are 150 seats in the legislature that must be apportioned among the three states according to their population. Show that the Alabama paradox occurs if the number of seats is increased to 151. So we're going to round the standard quotas and the standard divisors to the nearest hundred. So here's the populations. There's a total of 15,000 residents and there's 150 seats. So our standard divisor is 100. And so we take each of the state's population, divide by 100, we get the standard quotas. We're going to round those down. We add them up and we come up with 149. So we've got one more seat to be allocated and it's going to go to state A. So A goes from 7 to 8 seats. So here's the numbers that we have: 8, 67, and 75. Now we've got 151 seats now, so we're going to take 15,000, divide by 151, and our standard divisor now is 99.34. So now we're going to take each of the populations and divide by 99.34. Here's our standard quota. We're going to round down. We're at 149. Now we've got two additional seats to allocate, and where are they going to go? They're going to go to states B and C. So we end up there with 68 and 76, but remember that state A had 8 seats apportioned originally. So A's actually lost a seat, and so this is an illustration of the Alabama paradox. The population paradox occurs when Group A loses items to Group B, even though Group A's population grew at a faster rate than Group B's. Consider Alexandria, a small country with a population of 100,000 and 3 states, A, B, and C. There are 100 seats in the legislature that must be apportioned among the 3 states. Using Hamilton's method, here we can see the apportionment. So we take each of the populations, divide by 100, round down, we add those up, we have 98. We have 2 additional seats to allocate, and they're going to go to states B and C. Now, suppose the population increases according to the table below, show that the 100 seat and show that the population paradox occurs when we have Hamilton's method. We still have 100 seats to allocate. So state A had an increase of 399 people, and the percent increase for that is about 1.7%. And state B had an increase of 100, which is an increase of about 1.8%. And state C had an increase of 185, which is an increase of just 0.3%. So all three had an increase, but state B is increasing at a faster rate than A and C. So the new standard divisor now is 1006.84. So the initial, we're going to do the standard quotas here. We're going to round down, we get 98. We have 2 seats left to allocate, and those are going to go to A and C. So we end up here with 24 and 71. But remember, state B lost a seat to A, even though B's population was growing at a faster rate than A's, and this is an example of the population paradox. And finally, the new states paradox occurs when the addition of a new group and additional items to be apportioned reduces the previous apportionment of another group. Oklahoma Public Library has received a grant to purchase 100 laptops to be distributed between 2 libraries, A and B. The 100 laptops will be apportioned based on the population served by each library. So our standard divisor is 100. So we take each population, divide by 100. We get our standard quota, we round down. Add those up, we have 99 total allocated. We have 1 more to allocate, and it's going to go to Library B. Now, an anonymous donor decides to donate money to purchase 6 more laptops, provided a third Library C that serves a population of 625 is included. And we want to show the new states paradox occurs when the laptops are reapportioned. So now the total population is 10,625, and we're apportioning 106 laptops. So now the standard divisor is 100.24. So here's our standard quotas. We took each population and divided by the 100.24. We round down. We're at 105. We've got 1 more to allocate, and it's going to go to Library A. Now, if you remember, The original allocation, before C was added, B would have received 79 laptops, but adding the new library and increasing the total number of laptops, Library B ended up losing a laptop to Library A. This is a case of the new states paradox. Belinsky and Young's impossibility theorem said there's no perfect apportionment method that satisfies the quota rule. Remember, the quota rule said you had to use either the upper or the lower quota and avoids any of the paradoxes. And so here's the apportionment methods, the four methods across the top, and then whether or not they violate the quota rule, which Hamilton never does, and then whether or not they produce the paradoxes, and then also what types of states that they favor.